welcome back everyone. We are going to finish up our discussion of the first part of section 1.2 by talking about graphing functions on your calculator and then finding domains algebraically. So to start out with, we're going to graph each of these three functions on our calculator, get a good graph, figure out the domain from there, and then figure out why the domain is the way it is algebraically. So if you're going to put these functions in your calculator, the first thing you have to know is that the division bar acts as parentheses basically. So what we're saying is you got to do what's in the numerator, you got to do what's in the denominator, and then you take the numerator divided by the denominator. So to put this in your calculator for y1 is going to be this form: x plus 3 divided by the entire denominator, x squared plus 5x plus 4. So take a minute, put that in your calculator, use the Zoom standard window, and verify that you get a graph like the one that you see in the middle of your page here. Alright, if you're having trouble getting a graph of that, make sure that you ask your teacher about that in class so they can explain that to you. It's very important that you know how to do this on your calculator. As we talked about in the previous video, it is implied when these graphs run off the edge here that they are continuing on in the same pattern. Also, if you're using the Zoom standard window, the window for x goes from -10 to +10, and for y it goes from -10 to +10. Those are, you could think of them as the intervals for the windows. They're not the domains though. Also, the scale on each axis is 1. So each one of these tick marks represent 1 unit. So you will notice that at x equal -1 and x equal -4, there's something going on with this graph here. Well, let's write down our domain based on looking at the graph. The domain, the set of all x values that can be used in the function, is from -infinity to -4. The graph doesn't technically exist at -4. That's called a vertical asymptote or an infinite discontinuity. So we are not going to include -4. We're going to skip over it. We're going to start up again on the other side of -4 and go to -1, and we're going to skip over -1 and go to +infinity. So basically what we're saying with this interval notation is it's all real numbers from -infinity to infinity except for -4 and -1. So let's talk about why that happens algebraically. If you write this function out algebraically and take a close look at it, x plus 3 in the numerator, x squared plus 5x plus 4, it's not obvious just by looking at it in its current form that we've got some strange things going on at -4 and -1. But if you take a closer look, what you'll see is that the denominator is factorable. So factoring it is going to help us see what's going on. So x plus 4 and x plus 1. That function is just a fraction. It's just a complicated fraction. So if you think about what you can't do when you're dividing, which is what a fraction is, you can't divide by 0. So if you take a look at this, you will see that when x is equal to -4, the denominator is 0. And you can't divide by 0. It doesn't make sense. That's why -4 is not in the domain. You will also see the same thing at x equal -1. It makes the denominator 0. You can't divide by 0, so -1 is not in the domain. So I would like you to graph the next function, again using Zoom standard, and try and figure out what the domain is by looking at the graph on your calculator. Once you're done with that, unpause the video and we'll come back and figure out algebraically why it is the way it is. All right, so hopefully you were able to get that graph in your calculator. And again, if not, make sure you ask your teacher about that. But the graph goes from negative infinity in the x direction and stops at 9. And if we plug 9 in there, we do actually get a value out for y, or f of x. The square root of 9 minus 9 would be 0. So our domain is from negative infinity to 9, but we're including 9. Now, you might be asking, well, why does it stop at 9? Well, we are only working with real numbers right now in this course, so we're going to restrict our attention to that. So you have to think about, what kind of numbers can I take the square root of? You can take the square root of any number that is greater than or equal to 0. So if you run into a radical, you're going to want to take what's inside the radical and say that has to be greater than or equal to 0. Okay? So now we're going to solve this inequality, and we're basically going to subtract 9 from both sides and say the opposite of x is greater than or equal to negative 9. But now we're going to multiply or divide by negative 1, and as you recall, when you do that, you have to switch the direction of the inequality. So when we do that, we're going to get x is less than or equal to 9, and as you know, that is written in interval notation as stated over here below the graph. All right, last one here. Before we start though, I want to point out to you that there's a mistake in my notes, and this x minus 11 should be an x minus 1, and this x minus 11 should be an x minus 1. I will fix that in the notes that I post. So, the first thing I want you to do is go ahead and graph this, remembering that the entire numerator is in parentheses and the entire denominator is in parentheses. So in the denominator, you're actually going to have 3 sets of parentheses. The other thing I want to point out to you is that if you use Zoom Standard, you'll get a graph that looks similar to this, but what you're not going to see is you're not going to see this thing right here. If you look really close, that's a hole in the graph. Okay, so after you get this graph using Zoom Standard, hit Zoom Decimal and verify that you get this graph. So I'm going to pause right now and give you a chance to do that. All right, so hopefully you got that graph. Again, if you have any calculator questions, make sure you ask your teacher about that during class. This graph continues on in this direction forever, but it doesn't on this side. It actually stops right there. So we want to talk about the domain of this by looking at the graph, and then we're going to justify it algebraically. So the domain goes from negative 2. Now, the question is, do we include negative 2 or not? And the answer is we don't in this case, but we'll have to explain that. Goes to positive 1, skips over positive 1. There is no graph there, and goes from 1 to infinity. Now, that's not real obvious why that happens that way, but let's talk about this function. So this function is equal to x minus 1 over x minus 1 times the square root of x plus 2. All right, so again, this is really a fraction. So one thing you can't have is you cannot have a 0 in the denominator of the fraction. If you do, the function's undefined, and in this case, if x is equal to 1, you have a 0 in the denominator and the function's undefined. Now, why is there a hole in the graph here, whereas in the first example there was that vertical asymptote? That's because both the numerator and the denominator are 0 at x equal 1. So that's why we skip positive 1. The other part is this radical in the denominator. We already know from the previous example that we cannot take the square root of a number unless it's greater than or equal to 0. So anything from negative 2 and higher would work for taking the square root. However, if we include negative 2, we would be taking the square root of 0 in the denominator, so we can't. So we've got 2 restrictions here. X cannot be equal to 1, and x has to be greater than -2. So if you think about all real numbers and exclude x is equal to 1 and any number that's not greater than -2, you end up with that interval. So algebraically can be tricky, but sometimes it's actually easier than trying to figure it out by looking at the graph. So there's a few things you have to watch out for. If there's a radical, whatever you're taking the square root of needs to be greater than or equal to 0. If that radical is in the denominator, then you need to be taking the square root of a positive number. And finally, if you have a 0 anywhere in the denominator, it's going to cause a discontinuity of some sort. So that number or those numbers that make that discontinuity happen or make the denominator equal to 0 are not part of the domain. So that wraps things up for our discussion of functions and relations and domain.